on a photographic screen. So all these are characteristics of images formed by a plane mirror. So we can simply see that the option that is not there is D, which is magnified. So images that are formed by a plane mirror, very, very important, they are not magnified. Unlike that of concave and convex lenses. For plane mirror, you don't have magnification. So D is the right answer to this, because these are actually the properties of images formed by a plane mirror. They are erect, they are laterally inverted, they are same size as the object and same distance as the object. So, and they are virtual. So those are the properties. And from that, the option that is not there is magnified D. Thank you. Yes, let's look at this question number 6 for JAMB Physics 2018. What is the resultant resistance of the circuit given above? This is the circuit, and we are told to calculate the resultant resistance of this 3 ohm, 4 ohm, 2 ohm, and 2 ohm in this fig 4. Now, the options are A, 8 ohm, B, 11 ohm, C, 4 ohm, D, 3.6 ohm. So what is the resultant resistance? Now, for us to be able to do this calculation very well, we need to know the formulas for resultant resistance. If the resistance are in series, the total resultant resistance or the total resistance is R1 plus R2 plus R3. Then you continue adding. This is for a series arrangement. Now, if they are in parallel, it's going to be 1 over R total. It's going to be 1 over R1 plus 1 over R2 plus 1 over R3. So this is for parallel arrangements. So these are the two formulas for calculating. So like these 2 ohm and 2 ohm, they are in parallel. But the 3 ohm, the combination of these two and these are in series. So we're going to find out a way of doing this. So we can do these 2 ohms that are in parallel first. We can add them up together, these 2 ohms and 2 ohms. We can add them up together so that we will now have a direct something. So let's do it. Let's do it. Because this very figure shows 2 ohms resistor, these 2 ohms resistor, which are in parallel, but they are now combining in series with these 3 ohm and 4 ohm. So therefore, the total resistance will be given as shown. So we can now have our R total to be equal to, this one is in series with the both of this and this. So you can just say that you have here 3 ohm, this very 3 ohm, but these two are in parallel. So you can add the two of them together by saying that they are 1 over RT, they are in parallel, and they can be added by saying 1 over 2 plus 1 over 2. So you have this ohm, then plus this one is also in series with the total arrangement. So we have what? 4 ohm. So that's what we're going to have. Then 1 over 2 plus 1 over 2 is like having 1, because this is half and half is 1. So here we can have 3 ohm plus this thing that is equal to this is just saying half. And inverse of is just saying half plus half, which is 1. Inverse of 1 is still 1. So you have 1 ohm plus this 4 ohm here. So you can simply have how many? 3 plus 1, which is 4, plus another 4, 8. So the answer is simply 8 ohms. Very, very simple. You can also do it one by one by just finding this and this. This and this are in parallel. So you can have 1 over 2 plus 1 over 2, which is 1. Inverse of 1 is still 1. So that you now have 3 ohms plus 1 ohm, because this and this is 1, then plus 4 ohm, which will still give you 8 ohms. So the right answer here is 8 ohms. Thank you. So welcome. Let's start with this JAMB past question, Physics 2018, question number 7. Which of the following best describes the energy changes which take place when a steam engine drives a generator which lights a lamp? A. Heat to light to sound to kinetic. B. Heat to kinetic to electricity to heat and light. C. Kinetic to light to heat to electricity. D. Electricity to kinetic to heat to light. So what is the answer to this problem? Now, for us to understand this problem, we need to first of all know the first law of thermodynamics. Very, very important. The first law of thermodynamics, or you call it the law of conservation of energy. The law of energy conservation, which basically states that energy can go from one form to the other, but not created nor destroyed. Energy can neither be created nor destroyed. That is the first law of thermodynamics, or laws of conservation of energy. But can neither be created nor destroyed, but can be converted from one form to another. So that is what can happen to energy. Energy can move from being in the form of heat to light, or to sound, or to kinetic, or to any of these forms here. So energy can actually move from one form to another form. But in this situation, what is the movement of the energy? Now let's look at the problem in particular. Which of the following describes the energy that takes place when a steam engine, look at that, a steam engine. So how does a steam engine work? Now let's say you have a container and you have water inside this container. Now you have to apply heating. So this is heating. You apply heat to this water. When you apply heat to this water, what happens? The water gains kinetic energy and turns into steam. So you have kinetic energy being like heating. Immediately after applying this heat on this container, this water will turn into steam. So you know when a substance moves from liquid to gas, it means that it is gaining kinetic energy. So it gets kinetic energy because of the what? Heat. So you have, after applying heat, you have the water gaining kinetic energy. When it gains kinetic energy, what do you think will happen? If it gains kinetic energy, it is going to use the force of the motion of the water to turn the shaft of a generator in order to produce what? Electricity. So when it turns the shaft of a generator, it produces electricity. So you notice from heat to kinetic to electricity. Now what does this electricity do in this generator? What will it do? It will be able to if you have a lamp, like in your house, your electricity should be able to light up your lamp. Should be able to what? Light up your lamp. And as it's lighting the lamp, when you touch the lamp, you will notice that there is heat in the lamp. So you see the motion here from heat to kinetic to electricity to light and heat. So you see that the option B is the right answer there, because there is from heat, as we have here, you heat the container in order to convert the water to steam. That's what a steam engine does. Then the water gets kinetic energy when it's going from water to steam because of the increase in temperature. So there is kinetic energy. Then the force of this water or this steam in turning the shaft or in working in the generator generates electricity. And this electricity is used to heat and light up your lamp. So option B is the right answer. So option B is the option of the answer. Thank you very much. Okay, now let's look at this JAMB past questions physics 2018, question number 8. Cathode rays are A. High energy electromagnetic waves, B. Protons, C. Neutrons, D. Streams of electrons. So what are cathode rays? Are they high energy electromagnetic waves, protons, neutrons, or streams of electrons? Now, cathode rays are streams of electrons, and its effects can be observed using a cathode ray tube in a process known as thermodynamic emission. So, for us to understand this question very well, we need to state this fact that actually cathode rays are streams of electrons. That is what cathode rays are, streams of electrons. The effects of cathode rays can be observed using what we call a cathode ray tube. So when you check your textbook for cathode ray tube, you're going to see this very cathode ray and it works. And again, this is the process that actually happens in the cathode ray is what we call thermodynamic emissions. So whenever there is the application of heat, there is release of some emissions. Thermodynamic emission simply means ionic emission due to the application of heat. So when you have heat on a filament, you have heat being applied, then there will be emission of some ionic particles. In this time around, electrons. So when there is emission of electrons and these electrons move, we have what we call cathode rays. So you're going to look at this cathode ray tube and see how this motion is done in your physics textbook. Check on the ionic emission. We're going to read about cathode rays, and you see that actually cathode rays are actually streams of electrons. That is what cathode rays are, streams of electrons. So that is the answer to this problem. They are not protons, they are not neutrons, but they are streams of electrons. Thank you. Yes, welcome. Let's look at this JAMB past questions physics 2018, question number 9. A narrow beam of white light can be split up into different colors by a glass prism. The correct explanation is that A. White light is an electromagnetic wave, prism has all the colors of the white light. C. Different colors of white light travel with different speeds in glass. D. White light has undergone total internal reflection in the prism. So what is the answer to this problem? Now, for you to understand it, you need to understand some technical terms or phenomenon in white light. And here we're talking about dispersion of white light. What is dispersion of white light? We need to know what dispersion is. For us to understand this, we need to know what refraction, diffraction, internal reflection, all those things. So, but the phenomena that goes with this very particular case is what we call dispersion. So we say that a narrow beam of light. What happens to a narrow beam of white light? Can you tell me what that happened? It can actually be split up. A narrow beam of white light can be split up into different colors. You can do that. That follows from what we have up here by a glass prism. So if you want to split up a narrow beam of white light, you use what we call glass prism. So why does this happen? This is because, and this will give us the answer to what we are asking. Why does a narrow beam of white light split up when passed through a glass prism? It is because different colors of white light. That means in white light there are actually different colors inside it. Different colors of white light travel. These different colors of white light, they move. You will not see them until you pass the white light through a glass prism. They are actually different. There are actually different colors inside the white light, and they move with different speed. So whenever you pass them through a glass prism, you will not see that some of them moving. You will not see that they actually move in different speed, and you will be able to know that there are actually different colors. And of course, whenever something is moving with different speed, you can say it is moving with varying, that is also different wavelengths. So you will not notice this until you pass it through a glass prism. Different wavelengths in a gas prism, in a glass prism. So they actually move in a different wavelength. So you'll be able now to see the different colors in the white light. This effect is known as dispersion of white light. This very thing I just explained is known as what we call dispersion. Dispersion of white light. So whenever you're asked what is dispersion of white light, dispersion of white light is actually what happens when a narrow beam of light is split up into different colors because of its passage through a glass prism. And this happens because the different colors in this very white light travel with different speed and of course varying wavelengths. So you can see that the answer from the options is just option C, because here it is written that different colors of white light travel with different speeds in glass. So that is the answer to this, and it is known as dispersion of white light. Dispersion of white light. Thank you. Hello, welcome. Let's look at this question number 10 for JAMB Past Questions Physics 2018. Figure 2, this very figure here, represents a block and tackle pulley system on which an effort of W newtons supports a load of 120 newtons. If the efficiency of the machine is 40%, then the value of W is A, 28 newtons, B, 48 newtons, C, 288 newtons, D, 50 newtons. So what is the value of the W. This is the W here. So having this is the W from the question. This is the W and this is the load. So this is L. L is equal to 120. So take note of this. L is equal to 120. This is W, which is the effort. So this is the load, L, and it is equal to 120. Effort is W, and you are needed to find out L. Also note from this that we have how many pulley systems? We have 1, 2, 3, 4, 5, 6. So we have 6. So that means that the VR is equal to 6. So take note of these very things before we start the calculation. So from what is given, we have E to be equal to W, which is the effort. This is the effort. E equal to W, and that is what we are told to calculate. We have L, which is load. Load is equal to L, which is equal to 120 Newton is given. So E is equal to effort. We are supposed to know all this. This is basic things in calculations as this. Now, another thing that is given is VR, which we all call velocity ratio. VR, velocity ratio. I want to give us the formula before I start solving. How do you get this? By the number of wheels. Number of wheels. And I just counted the wheels. I have 1, 2, 3, 4, 5, 6. So VR is equal to 6. Now, having all this, we can now put the formula for efficiency, because efficiency is given us here as 40%. So efficiency, we all know in this calculation, is MA all over VR times 100 over 1. So that is what efficiency is. And we all know that MA, mechanical accuracy, is actually equals to load over effort. So with this, we can do this calculation effectively. So having known all this formula, we can now calculate efficiency again. Efficiency is actually equal to MA. MA is L over E. And L is 120 from here. L is 120 here, all over E. So in place of MA, I'm putting L over E. And you all know that E, okay, so L over E. So this is L over E. Then this all over VR. This is efficiency is equal to MA over VR. And MA is already L over E, which is 120 over E. So what is remaining is VR. So all this all over VR, which is 6. We know that VR is equal to 6. So times 100 over 1. So that is it. And we know that efficiency already is equal to 40%. So we can put 40 equal to 40. So what is left for us to make W is to make E the subject of the formula, which is the effort. And we know that E is the same thing as W. So we now have, in essence, 40, which is this 40, is equal to 120 over W. In place of E, now we are putting W because it told us that E is equal to W. The effort is W newtons. So all this all over 6 times 100 over 1. So if you do this calculation by making W the subject of the formula, you get the answer. So if we make W the subject, we have W to be equal to, and cancel out, we have W to be equal to 50 newtons. So W will give us 50 newtons. So the answer is D, W equal to 50 newtons. So how do we make this the subject? We have 40 is equal to 120 over W divided by, so you can say times 1 over 6, because it's divided by 6, times 100 over 1. So if you multiply out, you have 40 is equal to 120 times 100, you have 1,200. Yes. This is 120 times 100. We have 12,000 all over W times 6, which is W6. So when you cross multiply, you have 6 times 40 40 times 6 times W is equal to 12,000. So make W the subject, have W all over 12,000 all over 40 times 6. So if you cancel out, you get 50. So how do you cancel out? 0 here cancels 0. You have 4 here cancel 12, which will give us 3. So you have 300. So you have 300, 13 into 6 is 5 to 0, 0. So we have 50. So that's how we come about 50 newtons. So the correct answer is D, 50 newtons. Please note the formulas that efficiency is equal to mechanical accuracy over velocity ratio times 100 over 1. This is the formula that we use for this calculation. EFF, efficiency equal to MA over VR times 100 over 1. Now, also note that mechanical accuracy MA is equal to L over E, load over effort. This is the load here, and this is the effort that you're making to carry this load. MA equal to load over effort. Now, note that VR is the same thing as the number of wheels in this pulley system. So these are the formulas in calculating a pulley system. Efficiency is equal to mechanical ratio over velocity ratio. Mechanical accuracy over velocity ratio times 100 over 1. Mechanical accuracy is equal to load over effort. And velocity ratio VR is the same as the number of the pulley wheels in the pulley system. So take note. Thank you. God bless you. Welcome. Let's look at this question number 11 for JAMB Past Questions Physics 2018. The question goes, what type of reaction is represented by the following scheme? We have nuclear X, superscript 2, subscript 1, plus nucleus Y, superscript 2, subscript 1, to form nucleus Z with superscript 3, subscript 2, plus a neutron, superscript 1, subscript 0, plus energy. The options are A, fission reaction, B, fission reaction, C, chain reaction, D, radioactive decay. So how do we go about solving this? Now, for us to be able to handle this well, we have to note that there are two types of radioactivity, or two types of radioactive reaction. And those two types are, one, we have what we call nuclear fission, and number two, we have what we call nuclear fusion. See the two names, fission and fusion. So whenever you hear nuclear fission, we are talking about the splitting, breakup, splitting up of one heavy nucleus. So when you have one heavy nucleus breaking up to form lighter ones, to form a lighter, or to form lighter nucleus, two lighter nucleus, maybe of equal parts. Or you can say it is also the splitting into two approximately equal parts, or two approximately equal nucleus. And this breaking is actually with the release of huge amounts of energy. With the release of huge amounts of energy and neutrons. So when this happens, we say that we have nuclear fission. Whenever you have a big nucleus splitting together into smaller ones with the release of energy, we call it nuclear fission. But nuclear fusion is the fusing together, the coming together of lighter nuclei. So when you have two light nuclei coming together, that's smaller nuclei, we call it nuclear fusion. So when they are coming together, we call it fusion. When they are breaking up, we call it fission. So when smaller ones come together to form a heavier nucleus, we call it nuclear fusion. And this also happens with the release of energy. So whenever there is radioactivity, there is always release of great amounts of energy. So this happens with the release of large amounts of energy. Very, very important. So we have nuclear fission or nuclear fusion. So here, when you see fusion reaction, it also simply means nuclear fission. And when you see fission reaction, it means nuclear fission. So which of these explains this? You will see that when you look at this nuclei, this is 2 and here is 2, but they form 3. So you have smaller ones coming together to form big one with energy. Here is 1 and here is 1 and here we have 2. So we have this and this combining to form this. So you can say that this is actually nuclear fusion because they are coming together to form a bigger one. So anytime you want to study this, please, you have to take note of you look at the nucleus that you have on the other side, on the reactant side. If they are smaller, like the case we have here, these ones are smaller. We have 2 and we have 2, but here we have 3. So we have smaller ones forming bigger one with the release of energy. So we call it nuclear fusion. And that's why option A is the right answer. If they are breaking down, had it been this one is having like 1 or half, is lesser, then it will be fission. But when they are coming together to form a bigger something with the release of energy, we call it nuclear fusion. So nuclear fusion, or you call it fusion reaction, that is the answer. Thank you. Look at this question number 12 for JAMB Past Question Physics 2018. The amount of heat needed to raise the temperature of 10 kilogram of copper by 1 Kelvin is its A, specific heat capacity, B, latent heat, C, heat capacity, D, internal energy. Now, for us to be able to appreciate this question very well, we need to know the definition of these various terms. And we're going to start with number 1, which is specific heat capacity. Now, whenever you hear the word specific, you're considering 1 kilogram. Here we have 10 kilogram, and even we have 1 kilogram. We know we are talking about specific heat. So this definition still holds true for specific heat, but in this case we're having 1 kg. So specific heat capacity is the amount of heat needed to raise the temperature of 1 kg, it has to be 1 kg, of a substance. This time around we have copper, but it could be any substance or any metal, by 1 Kelvin. So that is what specific heat capacity is. Now number 2, we look at latent heat. What is latent heat? Latent heat is that amount of heat needed, the amount of heat needed to cause change in state. The amount of heat needed to cause change in state. That is when there is change from solid to liquid or liquid to gas without rise in temperature, So when latent heat is used, there is no rise in temperature. Now number 3, we look at heat capacity. What is heat capacity? Heat capacity is the amount of heat needed to raise the temperature, of a given mass, So this is a given mass, 10 kg, it could be 20, it could be 30. So provided the mass is not 1 kg, then we'll call it a given mass of a substance, by 1 Kelvin. So that is what heat capacity is. Whereas internal energy is the energy due to the molecular bonding. So internal energy is the energy due to the molecular bonding. So the molecular energy, the positioning of the molecules, that is what causes the internal energy. So from these definitions, we can see that C is the right option, because heat capacity is the amount of heat needed to raise the temperature of a given mass, say 10 kg, it could be 20, it could be 30, it could be 100 of copper by 1 Kelvin. But if this mass is 1 kg, then it will be specific heat. So whenever you hear the word specific, we're talking about 1 kg. But once it's more than 1 kg, we'll talk about heat capacity. And that is the answer to the problem. Option C. Thank you. Now let's look at this question number 13 for JAMB Past Questions Physics 2018. The electrochemical equivalent of silver is 0.0012 gram per coulomb. If 36.0 gram of silver is to be deposited by electrolysis on a surface by passing a steady current for 5 minutes, the current must be A. 600 amperes, B. 100 amperes, C. 10 amperes, D. 1 amperes. This should be in capital letter amp. The A's are in capital letter for amperes. Now, let us solve this. First of all, for us to be able to solve this, we need to recognize the fact that the electrochemical equivalent of a substance is the amount of the substance mostly in mass deposited by 1 coulomb of electricity in an electrolytic process. So that very amount is actually represented with the letter Z. Now, the relationship between mass deposited and the quantity of electricity is Q times Z, which is the electrochemical equivalent. And we know that Q is equal to current times time, IT. So we can now say that mass deposited is equal to current times time times Z. So with this, we can make current the subject of the formula I, making it the subject, we'll have M all over TZ. So that is what we are going to be doing to calculate the current. So the current is equal to mass. Mass as we have here is 36 gram, 36 all over T. T is the time. We have T here as 5 minutes. We need to convert it to seconds, so it's going to be 5 times 60. So times Z, which is the electrochemical equivalent, which is 0.0012, 0.0012. So if we solve down, if we press our calculator to solve down, we are going to find out that we have 100 amperes. And that is the final answer, B. And this is the B, 100 amperes. This is A. This is 6,000 amperes. This is 10 amperes. The A is in capital letter. So the right option is 100 amperes, because when you cancel out, 6 here is going to give us 6. Here is going to give us 10. So if you cancel out, you're going to have 100 amperes. And that is the answer to this problem. Thank you. Welcome. Let's look at this JAMB past questions, Physics 2018, question number 14. Shadows and eclipses result from the A. Refraction of light, B. Reflection of light, C. Diffraction of light, D. Rectilinear propagation of light. So which of the following causes the shadows and eclipses? What causes the shadows and eclipses? Is it the refraction of light? Is it reflection of light? Or is it diffraction or rectilinear propagation of light? Now, the right option is rectilinear propagation of light, because all these are caused by the movement of light in a straight path. So whenever you have your light and it moves in a straight path, if something is blocking it, you have what we call shadows and eclipse. And you know that eclipse happens when the sun is at the middle, then with the earth revolving around it, and also the moon revolving around the earth. So whenever the moon is in between the earth, this is the earth and the sun, you have what we call eclipse, which is a special kind of shadow that is being cast on the earth because of the blocking caused by the moon. And this is actually because the sun is emitting light that is traveling in a straight line. And motion of light in a straight line is known as rectilinear propagation of light. So whenever you hear the word rectilinear, it simply means movement of light in a straight line. Movement of light in a straight line. And that is why option D is the correct option. So rectilinear propagation of light is the movement of light rays in a straight line. That is what rectilinear propagation. And this rectilinear propagation of light causes so many things, not just the shadows and the eclipse. It is the cause of, number one, shadows. Shadows are caused by rectilinear movement of light in a straight line. Number two, eclipses. Eclipses is as a result of this. Then you also have applications like the pinhole camera. If you know about the pinhole camera that you use in physics, it is also due to the rectilinear propagation of light. And finally, we have what we call the ray box. The ray box. All these are possible because of the movement of light in a straight line, which is known as rectilinear propagation of light. So, refraction is another property of light, reflection and diffraction. But and when you talk about reflection, you're talking about when you have a plane mirror and you have the incident ray, then you have the reflected ray. Then when you talk about refraction, you talk about when you have a prism, then you have light coming here. Then instead of being reflected, it goes in here and comes out like this. This is refraction. So we have refraction of light. All these are different motions of light. This is reflection. So these are different motions of light. But the ones that are responsible for the very movement of light that is responsible for shadows, eclipses, pinhole camera effect, and the red box effect is the movement of light in a straight line, which is also known as rectilinear propagation of light. Thank you. Let's look at this JAMB past question physics 2018. Question number 15. Which of the following obeys Ohm's law? Option number A, all metals. B, diode only. C, all electrolytes. D, glass. Now, we should always know that whenever you talk about Ohm's law, it has to do with metals. And what is the statement of this Ohm's law? In order for us to get this well, we need to note the statement of this Ohm's law. And what does it state? Ohm's law states that the current passing through a metallic, you see why I say it has to do with metals, passing through a metallic conductor. So Ohm's law has to do with metals. So the current passing through a metallic conductor is directly proportional to the potential difference across its ends. That is the statement of Ohm's law, that the current passing through the metallic conductor is directly proportional to the potential difference across its end. And this law holds true provided that that is for the conductor, its physical components and temperature remains constant. So that is the statement of Ohm's law. In equation form, you can say that the potential difference is directly proportional to the current. And when you remove the proportionality sign, you will now put equal to, you introduce a constant, and that constant is known as resistance. So this is the statement of the Ohm's law, that potential difference is directly proportional to current. And when you remove the proportionality sign, you introduce the equal to and introduce a constant. The constant of proportionality here is known as resistance. And you can use this equation to calculate the current, resistance, or potential difference for a conductor. So from the statement of the Ohm's law, which I just stated now, you can see that the Ohm's law has to do with metallic conductors, metals. So from the options, you can see that the most likely is option A, which is all metals. Though I also think that some metals don't actually obey Ohm's law like that, like tungsten that is used for bulb. So the right option here is A, all metals, because in the statement of Ohm's law, we have that Ohm's law states that the current passing through a metallic conductor is directly, whenever you say directly, this is the sign, directly proportional to the potential difference V, provided that the temperature remains constant. And that is that. Thank you. question number 16 for JAMB Past Question Physics 2018. And the question goes like this. Which of the following statements are true of isotopes? I. Isotopes of an element have the same chemical properties because they have the same number of electrons. II. Isotopes of elements are normally separated using physical properties. III. Isotopes of an element have the same number of protons in their nuclei. The options are A. I and II only. B. I and III. C. II and III only. D. I and III. So which is the correct option? Now, for us to be able to appreciate this question very well, we need to know what isotopes are. So what are isotopes? And we know that isotopes are, or is actually an existence. That's what isotope is. The existence of atoms. It's a phenomenon where atoms exist. And those atoms are of the same existence of atoms of the same atomic number. Atoms of the same atomic number. And whenever you hear the number, atomic number, it simply means the number of protons. Atomic number simply means proton number is the same. So when there is this existence of atoms of the same atomic number and the same properties, the only difference between this atom is actually that they differ in their mass numbers. So when you have atoms of the same atomic number but different mass numbers, then you know that the phenomenon known as isotopy is happening. So isotopy is a phenomenon whereby atoms exist in the same atomic number but having different mass number. And whenever you talk about mass number, you are talking about the number of protons. That's the proton number plus the neutron number. So proton number plus neutron number, that is what mass number is. So if you have an atom that has, let's say, 9 protons, 2 of them having 9 protons, but because one is having 10 electrons and the other one is having 12 protons, this one is going to have mass number of 19 and this one is going to have mass number of 20. So you see that their proton number is the same but their neutron number is different. So that is what we call isotopy. And how you notice that the proton number is different is that their mass numbers are going to be different, because mass number is proton number plus neutron number. And note that proton number is always equal to electron number. Why? Because the atom is electrically neutral. So from this we can easily pick out the answer, because I says isotopes of an element have the same chemical properties because they have the same number of electrons. Yeah, because their proton number, like I said, the proton number is equal to electron number. That means they have the same number of isotopes have the same number of electrons. So I is correct. Now, isotopes of elements are normally separated using physical properties. We don't know of this fact, so this cannot be true here. But the you have isotopes of an element have the same number of protons. That is what I said here. So this is also correct in their nuclei. So we have option I and III to be correct. So this B is the right option because I is correct and III is correct. So we are very sure about these two. We're very sure about I for isotopy, and we're also sure about II for isotopy. So if we use elimination method, can easily pick option B as the right option for these, because isotopes are existence, or you can say isotopy is the existence of atoms of the same atomic number, that is proton number, and properties. They have similar properties because of this similar proton number, but they only differ in their mass numbers. they differ greatly in their mass numbers. So that is the end for this. Thank you. Let's look at this JAMB past question. Question number 17 for Physics 2018. In the diagram above, the hanging mass M2, this is the hanging mass M2, is adjusted until M1 is on the verge of sliding. The coefficient of static friction between the mass M1 and the table is option A, M1 over M2, B, M1G over M2, C, M2 over M1, D, M2G over M1. So how do we go about solving this? Question number 17. Now, in order to be able to appreciate this question, we need to understand what coefficient of static friction is. And coefficient of static friction is actually the frictional force F all over the normal force R. So that is what coefficient of static friction is. Then basically, looking at this diagram and looking at the options that we have here, you can simply relate this by saying that U is the force by this M2, which is mass times acceleration due to gravity, all over the force by this M1, also times this acceleration due to gravity. So if you cancel this D and G, you will have U to be equal to M2 over, that is C, as being the option and the correct answer for this. So C is the answer. Thank you.